Okay, hello guys, and welcome to my channel. Now here in this video, you want to find the values of a and b such that a to the power 4 plus 4 times b to the power 4 is going to be equal to 0. In other words, find the values of a and b such that this equation will be satisfied. Okay? Now, well, let's cut the equation part by part. I'm going to start by talking about a raised to the power 4, then we talk about b raised to the power 4, okay? Now, looking at this, a raised to the power of 4, it has an even power, and if you have plotting a graph of x raised to the power of 4, see that there is no way you can have a negative result from it, alright? So for all the integers we can ever plug in, or from even the real numbers, a raised to the power of 4 will always be non-negative. That is, it will always be greater than or equal to 0. The same goes for any number b. So b raised to the power of 4 will always be greater than or equal to 0 for any input b. Alright? And from here we saw that we multiplied that with 4. So even though if you multiply this with 4, it's still going to give you the same case. So the result will be greater than or equal to 0. Now, that means that if I add these two inequalities together, I'm going to have a raised to the power of 4 plus 4b raised to the power of 4 to be still greater than or equal to 0. Of course, it's going to be true. Now, from our original equation, we saw that this should be equal to 0. That means it should not be greater than 0, alright? So we should find the values of a and b that it will be equal to 0 strictly. So that tells us that we will only be looking for the values that this will be 0. Now, having the sum of two numbers to give you 0, where the two numbers are non-negative, that means that the two numbers should be 0. That is, a to the power 4 cannot be negative, okay? And b to the power 4 also cannot be negative. That means that let me just put it down, for a raised to the power 4 plus 4b raised to the power 4 to be equal to 0, it implies that a raised to the power 4 is 0 and b raised to the power 4 is also 0. So that is what I'm saying, okay? The sum of two numbers are giving you 0, where the two numbers cannot be negative. It means that the two numbers are going to be 0. So if a raised to the power 4 is going to be 0, it means that a is going to be 0, and again, and b is going to be 0. So with these integer values, we can now put this back into the original equation, and we're going to see that a and b are going to be 0. And that should end the video. Okay, but we can also look at this in another way, alright? I can try to factor that from the idea we have from the Sophie Germain, the French mathematician, who shown us how to factorize this kind of expression on the left-hand side, alright? It's actually called Sophie Germain's identity. Well, let me just put it down for you guys to see. So, this is actually a clear proof, but we can also look at it in another way. Why is my still writing it up? Sophie Germain identity, a female mathematician. She showed us how to actually factorize something like this by saying that a raised to the power of 4 plus 4b raised to the power of 4 has an identity. So I'm going to go ahead and try to do what she did. Okay, this is going to help us. That's why I'm actually bringing it in. Okay, so we are going to do this, alright, and we're going to equate it to 0. And when we do that, we can actually go ahead and solve for the values of a and b. Okay, so this I'm going to start by first of all equating this to 0. Now on the left hand side, I can rewrite it as a squared, and I square that is a raised to the power of 4. Okay, again, I add it to it. Well, this can be written as 2 squared and b squared and then the square of this. Alright? So that's another way of representing that. I'm actually doing that because I want to get a squared and then the square of this plus 2b squared, and then the square of everybody there, because it's just a product of squares. Okay, now I want you to recall that when you have a plus b or square like this, it is the same thing as saying a squared plus b squared plus 2ab. Alright, that means that a squared plus b squared is going to become a plus b all square minus 2ab. So in place of sum of two squares, like we are having here, this square and that square, I can look at this as this right hand side, alright? Okay, so knowing that when we have the sum of two squares, we will write it as let me use the capital letters. So this is going to become a squared plus 2b squared, and I square that, minus 2a squared times 2b squared, like this, alright? And that is equal to 0. Okay, so I can again simplify this a little bit, and we're going to enter with a squared plus 2b squared, and we square that, minus 2 times 2 here is going to give us 2 squared. We have a squared and we have b squared like this, and we equate that to 0. So we see that the second term on the left hand side is all squares. Okay, so we just write it down as a squared plus 2b squared, and we go ahead and square this, and we subtract 2ab all square from it. Okay, and still equate that to 0. So we now observe that we're having a difference of two squares here, and we know how we deal with them, right? We just take the first term, subtract the second term from it, multiply with, add the two terms together. That is to say, we're going to have a squared plus 2b squared minus 2ab times, again, a squared plus 2b squared plus 2ab, and we equate that to 0. Okay, so that's a nice thing to do. But from here, we see that the product of two expressions is giving us 0. And by the way, this last expression on the left-hand side is actually called the Sophie Germain identity, alright? So she showed us that we can actually factor expression of this form, and that is what you get. So I'm just going to use this as an equation and solve for the values of a and b. So I'm going to erase this part of the board, and we will continue from there. Okay, so here we have that the product of two expressions is giving us 0. It means that one of the expression could be 0 or the other could be 0. So that would lead us to having two equations, and luckily enough, they are just two unknowns, so it is very good like that, alright? So we just go ahead and equate one of them to 0 and equate the other to 0 as well. And we also take a squared plus 2b squared plus 2ab to be equal to 0. So we can state it to be equation 1 and equation 2. Okay, so from these two equations, well, if I add the two of them together, we will still have a and b's. And even if I subtract, it's only this thing that will be off, but we still have a and b. So I'm not going to do it like that. Rather, I'm going to do a little of a substitution, and that means from equation 1, let's talk about, I can rewrite it as a squared, I put this down, minus 2b times a plus 2b squared is equal to 0. So I decide to write this down as a quadratic term, okay? As a quadratic equation where a is a variable and b is a constant. So with this, I can use our quadratic formula, and I talk about the two values of a and b, the two values of a to give me negative of b, that is just 2b, plus or minus the square root of b squared, which is just going to be 4b squared, minus 4ac, so that is 4 times 2b squared, alright, divided by 2a. So that is it, alright? Okay, so from here, I can just have it that we're going to talk about A is equal to 2B. Okay? Right. So we're going to have A equals to 2B plus or minus the square root of. Now, in here we'll be having 4 times 2, which is just 8. So negative 8b squared. So 4b squared minus 8b squared is negative 4b squared. And in the denominator, we just have it to be 2. Here, under the square root sign, if we just want to evaluate this, we're going to enter with 2, that is square root of 4. The square root of negative 1 is just the iota, and we just put this down as b, alright? And I can add it with 2b. Okay, I divided by 2, and this is equal to a. So here we just have two values of a, which the first one is that a is equal to b plus ib, or b minus ib. We can also write it as a equals to b, then in bracket of 1 plus I, or b, then in bracket 1 minus I. So that is the case for the a. Okay, so given that those are the two values of a, to solve for b, I'll be using the equation 2 to substitute the two values of a into that. So I say substitute, that's just substitute, alright? Substitute a into 2. So this is the equation 2, right? So by doing that, let me take it one after the other. When a is equal to b plus 1 plus I, so that is going to give us b squared, then 1 plus I squared, then we add it with plus 2b squared, and we add it again with plus 2, then in place of a we just put it down, b, then in bracket 1 plus I will multiply with b again, and we just equate that to 0. Okay, from here we can just see that this is b squared, and we can just factor that. We're going to have that b squared is, out of the bracket, you have 1 plus I squared, okay, plus 2, b squared will be out, 1 plus I, alright, and we just equate this to 0. Now, looking at this expression right here, there's no how it's going to be 0. So, we're having the product of two terms, b squared and this, to be 0. It follows that any of them will be 0. But the second term here are just constants, and it is not 0. That implies that b squared is equal to 0, which means that b is 0. So if b is 0, then a is equal to, if b is 0, then a will be equal to 0 times whatever the case, which is just 0. So for a being 1 plus I, when b is 0, a is just going to be 0. Okay, remember we were talking about two values of a, this is plus and this one is minus. So when we are talking about the negative case here, we just substitute that for a into equation 2, so the only difference will be this as a minus. And if we just take it out, we will see that this place is going to be minus and minus. And again, it is still going to be that b squared times this is going to be 0. This one, in terms of the minus, is not still going to be 0. So b squared is going to be the 0. So that follows that a is also going to be 0. So that means that for the two cases, a's and b will be zeros. So from there, it also shows that the values of a and b here is, or they are just zeros. So a is 0 and b is 0. That there are no other solutions to that. Okay. So that is just the solution to our Diophantine equation. Alright, thanks for watching. Thanks for subscribing as well.